All right, what we're gonna do now is sort of tie up loose ends in our game, tidy up a few things and make some tweaks and add a bit more functionality so that the game's better prepared for when we create the final build in the next lesson. And after that lesson, we'll move on to a bit of a crash course on making a 2D platformer, which will show you how to tap into the Unity physics engine for moving objects and collision detection and so on. So for this lesson, the first thing we want to do is we'll tweak, or actually we'll fix a bug that we created in the power-up controller in the last lesson. Perhaps you spotted it and fixed it yourself. It's a real simple fix, but basically the bug prevented our power-ups from getting destroyed because now that we're using floats, it's highly unlikely that we'll end up with a counter that is exactly equivalent to 140. So all we have to do here is just make it greater than that, and that will fix that bug. All right, the next thing I want to do is let's just put our cube and sphere objects at opposite sides when the game starts. So minus 4.35 and 0 for the y there for the cube. And for the sphere, we'll make it 4.2. And I found that the music was a little quiet, so we have the music loops here. So music loop 1, I think, would be best set at 0.7. And music loop 2, a little bit louder at 0.8. And I'll save this scene and want to change the loudness for the start section here as well. This one, let's make that 0.6 and then save that. Also, I found the crowd cheer was a little bit on the loud side, so that's here, this one. If we have a lot of spheres on our screen, it's going to just multiply and overlap and going to get a little bit too loud, so just make that 0.45. And here we have these sprites, and kind of did a hacky thing here where we put it on the enemy layer. Really no point for that. Just put on the player 1 layer and put it on order 1, because I think the cube is on 0, right? So that'll ensure that the game over sprite will be above everything, which is basically what we want. And over in the sphere controller, I realized that the game gets a little bit too difficult once we have a lot of spheres or eyes on the screen, right? So I thought a good idea would be to spawn the enemies around the sort of face-off circle in the middle, so that you can kind of strategize and go to that middle area before a spawn occurs, so as to maybe escape the next wave. So we'll just make sure that the enemies spawn around that area by employing this bit of code, which by now we're kind of familiar with, right? To return either -1 or 1. And now it's going to be 1F to 6 point, well, just outside the bounds or at the edge of the arena, 6.4F. And this would be 1F and 3.5F, and the same thing. And there's this play delayed issue that we've been having hang around for a few lessons, and that's because the play method here that takes in a ulong has been deprecated. So still able to do its job, but because it's been deprecated, who knows if it's going to do the job as well as we're hoping, or if it'll be even functional in later iterations of Unity. So may as well employ play delayed now, which is what the error was, or the warning was telling us to use now instead. So play delayed, now it takes in floats. So what we'll do is we'll just pass in a random value that we get from random range method, anywhere between 0.01 and 0.3 seconds. Another thing I wanted to add was pause functionality to the, we'll do it in the World Manager, so head over there, and this will allow us to pause our game. It's not going to be perfect, but it's a nice little bit of functionality to have. So let's start off with a field here, a bool called pause switch, and we'll make a method called game pause. I'll just call it here even before we made it, just so I don't forget, as I'm prone to do. And we'll make that method right now. Game pause. This method will just check for, we'll say if input.get key down, and we'll assign it to key code P, so the P key will cause the game to pause. Or if we have a game controller, input.get button down, we'll say start, and we'll switch the bool to the opposite value. And here we'll have a conditional. If pause switch is true and not game over manager dot is game over, right? Shouldn't be able to pause the game when it's game over, right? What we'll do is, this is how we're going to pause the game. We're going to access the time scale through time, the time class, time.timescale equals 0. So it behaves exactly as you expect. The time scale sort of handles the progression of time in the game, so if you set it to 0, there's no progression. So that's how that works. I also want to disable the cube controller because we don't want to allow us to use any inputs. So get component. So make it enabled equals false. Else if not pause switch, in other words false, and not game over manager dot is game over, we'll switch the pause and we'll go back to regular time scale, in other words unpause. So time.timescale equals 1. And now we'll just re-enable that cube controller script so we can go back to playing the game, read our inputs. Just going to quickly test that out. Yep, great. And the cube animate, I think this sort of just looks funny having these old iterations here, these methods that use different types of iterations, but I want to let it hang around so that you can reference it if you need to later, so just comment this out. And now we'll want to disable the Power Up Manager script on game over. So go to the sphere controller, and when it's game over, just put that above there. We'll say, well, say game object dot find power up spawn, and then we'll use get component to return the Power Manager script. and we'll assign that to a local reference, Power Up Manager. Call it Power Up Manager with a lowercase p. And we'll say Power Up Manager dot is powered. So we'll also want to disengage power up, so we'll say it's false. On game over, there's no reason why it should still be in power up, and have the camera zoomed in and all that. So this will also zoom out the camera. And we'll say Power Manager dot enabled equals false. And next we should have the horn stop playing when it's game over. So let's go over to the World Manager, and in the pre-spawn air horn, we'll have a little conditional check here. If not game over manager dot is game over, then we'll play the audio, only if it's not game over. All right, the next thing I want to do is sort of clean up the font for our heads-up display. It's kind of not been looking very good, and might as well put it in some sort of finished state before we have the final build. So let's go over to the heads-up display. Now what we'll want to do is we'll want the font to scale when the screen size is smaller. This will really only affect how our game looks in the editor, right? But you may have been noticing that the fonts stay the same size regardless of whether or not you're playing the game in the editor scaled down, in other words, not maximized on play, and the fonts stay the same when you are maximized on play. So to make sure that the fonts scale, and to show you how to do that, here in the heads-up display, we'll just add all this code. So we'll say private int font size and public GUI style. Kind of a funny sounding type, huh? GUI style, and we'll call this font style resources to signify the resources in our game, not the scoreboard. That'll be another GUI style. We'll say equals new GUI style, and we'll make one for the scoreboard. We want this to be, slightly different for the scoreboard, just for the appearance of the game to look a little bit more interesting. So call that font style score, and in the editor we'll be setting some of these attributes in a moment. So now I'll say also public int offset. This will handle sort of a drop shadow effect. We'll have another game object as a drop shadow, and we'll specify the offset in the editor as well, so that it's just a little bit offset and you get that drop shadow effect. And we're going to need a font, so in the assets here, make a new folder. We'll call this fonts, although we'll only use one right now. And I'm going to import this asset. This is a freely available Microsoft created asset called Trebuchet, font asset. It's the best one I could find for this task. I'm not totally happy with it because it's not going to look as nice in our game when everything is all pixelated and retro looking, whereas this font is sort of nice, has nice curves and everything. And well, anyways, I'm sure there's ways to do this better using bitmap images. You can take that on as a challenge to do it that way if you want, but at this point I just want to get the font looking halfway decent before we're done with this project and not get too complicated. So we're going to use this font as the basis for our GUI style font here. So in start, we'll have a start method, say font. We'll assign this font to both font style resources and the font property, as well as font style score. Remember, this is that kind of funny assignment notation we saw before. Resources.load will load a font from our font folder by passing in the string to reference it, fonts / treb ucbd. I think this is the bolded version. Yeah, I'm just doing this all in one line just to, make it look a little cleaner. Now here, what we'll do is, instead of having a constant value for the rect here that we passed into the label, we'll make it relative to the width and height of the screen. So here, say screen dot width divided by 85f, and then plus offset. And here for the height, I figured this value was best. You can play around with these values to sort of see what they do. It's hard to explain why I chose these numbers. And we'll no longer need this formatting. Actually, I don't want that text there either, so we'll just remove this string format that we wrapped around that. We'll also want a font style passed in, and we'll also apply this to the other labels. We actually can comment this out because we'll determine the color in the editor. And to handle the scaling, we'll just have a method that we can call in the onGUI method. So private void scale font size, and the field font size will be equivalent to screen.width divided by 64. This will scale it depending on how wide the screen is. Make sure to call this method we just made scale font size. And also, I don't want the score to appear unless it's greater than 0, so we'll just wrap this around a conditional. So if world manager.grant total score is greater than 0, then and only then do we want to display this score. Now here in the editor, because we made the GUIStyles public, we have the GUIStyles here, and you can determine all sorts of properties here. We're not going to really worry about too many here. You can even establish the font. We did that in code, but as well as the size as well. But right now what we're going to do is we're just going to change the color. So under normal, let's say make it we had a sort of magenta before, so just like that. And the font style, make it bold. And rich text is on. And for this one, the offset is 0. For the, what we'll do is we'll copy this and put it in its own child game object and then make it offset, and that'll become the sort of drop shadow. So Control C, copying this game object. We'll call this HUD shadow. And for this, what we'll do is make this black. Will also be bold. And the offset will be 1. And we want to do the same thing for the score. for the score for the parent game object, for the GUI style for the scoreboard, we'll make it bold, and for the color, sort of be cyan, I guess, something like that. So this one looked good to me. And to sort of create this blooming effect with the scoreboard, what we'll do is we'll make an addition here to the world manager. We first have to determine whether or not we're actually scoring, so we'll do that with this, a public static bool we'll call isScoring. And we'll create a private method here. Actually, it's going to return a bool, so we'll say private bool scoring check. We'll take in an int, which will look at the previous frame's score, and another int, which is the current frame score. What we'll do is we'll just check if the previous frame score is less than the current frame score to determine whether or not we're actually scoring. Else return false. Now in the get close call score, here we'll capture the previous frame's score before it goes through all this calculation and gets the new score by assigning it to a local variable we'll call previous grand total score. It will be the grand total score before the calculation. And then we'll assign isScoring, the bool, to the result of the method scoring check, and we'll pass in the previous grand total score and the grand total score now after the calculation's been made. So now that we know whether or not we're actually scoring, what we can do is we can lerp the scoreboard to sort of have this blooming effect when we're scoring and look a little bit more interesting. So for that, back in the heads-up display, we'll say create private method, private void font bloom, we'll call it. I'll take in a GUI style. We'll say size factor equals, we'll do a little ternary here. If world manager is scoring, then the size factor will be the font size for the script times 4. Else it will be the font size times 2. And then here we just say font to scale dot font size equals math f dot lerp, and we'll lerp the font to scale. In this case, will be the scoreboard font. We'll lerp the font size to whatever the size factor, and we'll do it at this rate. And because that returns a float and the font size is an int, we just cast all that to an int. So it's a whole number, right? Fonts are measured in whole numbers. You can play around with these values and see how it affects the positioning of the font and run the game at maximum screen size as well as not maximized in order to see how this affects the positioning of the labels. All right, that's it for all the little tweaks that we need to do. In the next lesson, we'll actually build the project, so I'll see you there.